Okay, then we have the pilot relay protection scheme here, which we are going to see lastly, but not the least. This pilot relay protection scheme is similar as well to the distance protection relay, and also similar to the differential protection relay scheme, because it also utilizes two current transformers at the two ends, right? And also distance protection scheme because you need pilot wires to run all through the line. Okay, so we have the schematic that is shown here. Generally, the communication, the line is simply a communication, or what we call pilot channels here are simply communication channels, right, that are used. And we have various configurations or various types of communication channels here that can be used, or the pilot channels. We have the separate wire circuit, here the separate wire circuit called the pilot wires. We also have power line carriers and microwave channels. So those are different types of channels that can be used. For example, we have the pilot wire scheme here. So you see the two current transformers here at the two ends to protect the line. Then you have a pilot wire that runs all through the line. Meanwhile, in the power carrier here, you rather have what? You rather have line traps and coupling capacitors with radio frequency chokes here that are utilized in order to transmit and to receive signals, or signals through in the power system network. Sorry. Okay, so what are the function of these line traps? These line traps generally are set at the carrier frequency in such a way that they permit, okay, the protection scheme to operate only for faults within the zone or within that line. It will not operate as well for faults out of the line, out of for external fault. Let us put it in that manner. Okay, right. External fault will mean might be fault beyond bus A, that means before this bus A or after bus B. So they won't protect for those faults. So those are the use of those line traps because they are set at the carrier frequency in order to ensure that they only protect for faults within internal faults. Okay, then we have these coupling capacitors as well. These coupling capacitors can be used also for voltage measurements, and not only that, and they are also used in tuning of these also use tuning of the line frequencies, because we have this radio frequency choke. The radio frequency choke here permits to set the impedances for, because it permits to set low impedance for the power frequency, and a high impedance for the carrier frequency, right? Okay, so we have this is different from the pilot wire protection scheme, right? The wires doesn't run all through the line, but you have here transmitter and receivers that can be tuned, right? That's why we have this line tuner that is specified here. So the frequencies can be tuned. The frequencies relates with respect to the capacitance and inductance. So you can tune the capacitance and inductance values here to tune the frequency at transmission, the transmission or the transfer frequency, and so on and so forth. Okay, so that's it for the pilot wire protection scheme. So it's just for you to understand the pilot wire protection scheme. Yeah, you can reach more, you can study much more on the pilot wire protection scheme, on the directional protection scheme as well. Okay, thank you very much through the course of power system protection. And okay, we have the various types of protection network. In fact, generally, the power system can be divided, the power system networks can be divided into three main networks: the radial system, the ring main system, and the interconnected or mesh system. Okay, so this how you can interconnect your network. Radial system here, we have seen the radial system here. Larger system implies that you have your consumers being supplied on is by single feeders. In a case that if there is a fault on that feeder that is supplying those consumers, all those consumers on that feeder will be disconnected from supply. So there will be an outage. This is an example of the illustration of the radial distribution or the radial network system in such a way that here you have distributors. Here's a feeder. So if there's a fault on this feeder, this the whole of the distributor is off. So the consumers connect on this distributor off, right? Okay. Same thing here. If there's a fault on at the level of this feeder, all the consumers connected here are off. So that's the disadvantage of the radial network, right? And another disadvantage is that for the radial network, the consumers at the end of the network might experience what a low voltage. Okay, so the end consumers, yeah, experience low voltage. That is, the consumers at the end of the distributor might experience low voltages, not as those that are closer to the feeders or closer to the distributor. Okay, so those are the disadvantages. So we have as well uh, the ring. We can study much more on the advantages that has been illustrated there, disadvantages. The ring distribution network here, the ring distribution network here uh, is very, very much appropriate than the radial system network because the ring distribution network, the distributor or the consumers connected through the distributor uh, are supplied from two feeders in such a way that if there's a fault on one feeder, the other feeder is going to supply them. But note that in the ring distribution network, we have just one substation or one generating station, right? Or let's say one substation. We might have many generating stations, but all interconnect at one substation here, which supply the consumers now through a ring network. You see the feeders here connected in the ring. We have four feeders here, one from S to M, another from M to O, another from O to Q, and from Q to S. So those are four feeders. So consider that there is a fault uh, on feeder SM, right? Consider there's a fault here. So this place is disconnected, right? Power will still flow through SROPN to M. And you see the loads connected still on that are still connected in the network through this other feeder. So that's an advantage of the ring distribution network compared to the radial distribution network. Then we have as well the interconnected. So we have disadvantages and advantages, right? So advantage as well is that there are very less voltage fluctuations at the consumer's terminal, unlike in the radial system. Okay, then we have the mesh or interconnected system network, right? It is still a ring system network, but now on the feeders we have many substations, not only one substation or many power stations. Let's consider substations. There are many substations at the level of the feeder in such a way that if there is a fault on one substation, the other substation still supplies the feeder. So that's a major advantage and it's very, very, very good. So interconnected systems are the best, right? So those are